Hi, I'm Matthew Hernandez. Period 6 is December 6, 2019. And this is my video on Newton's 3 laws of motion. According to the textbook, Newton's first law of motion says that an object in motion will stay in motion and an object at rest will stay at rest unless acted on by an unbalanced force. So a first example that I have is the hat on the table. So this hat is seen remaining at rest, though this only works because of the balanced force between the two objects. There is an equal force of gravity pulling down on the table and pushing up on the hat. This is an example of inertia. This means the hat will remain still on the table until something or someone moves either of the two objects. Another example of Newton's first law is this phone sliding across the table. The phone represents an object in motion stopping due to an opposing force. As the phone slides across the table, we see it comes to a halt. This is because of friction being created from it sliding against the table and air pushing against it as it slides. The opposing force caused the motion of the phone to stop. If this force was not acting against the phone, it would continue to slide across the table and follow the first law of an object in motion staying in motion unless another force acts on it, just as it did in this situation. Newton's second law of motion states that the force of an object is equal to its mass times its acceleration. An example of the second law is me using force to push these two tables. Okay, so the smaller table has less mass than the larger one. So I applied the same force to the smaller table and it moved faster than the larger one did. So this means it would take more force to push the large table to reach the same acceleration as the small table did. But since I didn't, it was harder to move the larger table. Another example is these two objects that are also unbalanced. Okay, so the two objects are dependent on the force acting on them and their mass. The net force of the two objects is different, so they have different impacts when hitting the table. Although they may appear to be the same size, the rock has a greater mass, therefore a greater net force, causing a greater impact when it hits the table. Newton's third law of motion states that for every action, there is an equal and opposite reaction. So it's relevant to walking. When I walk, I am the action force exerting my force onto the ground. Then the ground is reacting as the reactant force by exerting its force on me. So the force I am applying to the ground is being exerted back on me with an equal amount of force. This allows me to move forward as I push back on the ground, and it pushes back on my foot in the opposite direction, making me go forward. Another example is this pencil hitting the floor. The pencil, being the first acting force, exerts force on the ground as it falls down on it. The floor is the second reaction force. It receives the pencil's force, then equally exerts it back in an opposite direction. This is why the pencil bounces back up instead of just hitting the floor and staying there.